Hi, this is part two of chapter one of the book Applied Statistics for Psychology and Human Factors in R. There's a link to where you can get this in the description, or you could copy this URL down, and this gets you directly to a PDF of the course book. So in this video, we're going to cover 3 or 4 pieces that are just getting your feet wet using R, including data types, changing between data types, filtering and selecting and removing data points, and how you do that, and then how to use R Markdown to create sort of documents, and a little bit of the philosophy for file management. Okay, so let's start with data types, and there's underlying any set of data, each data has the possibility of having a different type. A type of data could be a number, for example, but there's a bunch of different types of numbers. It's really, if you have you may know that a whole number like this is often considered an integer. It's in R, it looks like an integer, and it behaves like an integer, but it's usually not actually an integer. You can tell what type something is in one of 2 ways. You can do the str function. Let's see, and that tells you it's a number. Or you could do the type of str. Type of the number. So numbers are stored as sort of a general number, but if you see here, it's actually a double. That means it's a floating point double precision, which is really, really precise, except if you get really big or really small. So for most integers you deal with, you don't have to worry. Even though it's really a double, it's treated as an integer. Curiously, if you do something like 1 to 10, and try to look at this, that's stored as an integer. Integers can be smaller memory-wise, but they're half the size of doubles. Also, it can be faster if you do arithmetic, adding and subtracting and multiplying with integers in some specific cases. If you're doing something very intensive, you may want to use integers. So you can force a number to be an integer if you need it to be. But generally, things that look like integers are just stored as floating point numbers in R. And it hardly ever matters. But more often, you're dealing with values that are not specifically integers. You might have a response time, which could be 3.5 seconds. And if I do type of 3.5, you see it's a double. I can convert these between one another there's a set of functions that are called casting functions. So I could say as integer 3, it looks the same, but if I do the type of function, now it's an integer. So numbers generally are stored as doubles, floating point numbers. Another thing that you'll often have are characters. So you might have a data set that has subject codes or conditions saved as character strings. And characters have to be in either single or double quotes. Single quote will make a character string with quotes on the outside. I think there's maybe a few cases where single and double quotes differ, but I don't remember for sure. If we try str of 1, you see it's chr1. If we look at type of 1, it says it's a character, so this is a character string. There's also logical variables. Logical are true or false. So true can be written T or true. False can be written F or false. In fact, true can be written 1 or false can be written 0. So all these things are identical. In fact, if you do, you can test whether things are equal. So you can say T is equal to true, and this is, yeah, that's true. If you do T is equal to false, that's not true, so it's false. If you do T is equal to 3, that's not true. But if you go T is equal to 1, that is true. So T is just sort of a fancy way of writing 1. F is equal to 0. False or F is a fancy way of writing 0. So much so that if a lot of times, let's say you want to test for something and then pick the first or second element of a vector based on whether it's true or false, you could do, or maybe you want the third or fourth element of a vector based on it's true or false, you can do, let's see, sample CT F 10 place equals 2. So here's 10 true or false values. If I add 2 to this, all the falses become 2 and all the trues become 3. So this is just a very simple way of taking a true or false and transforming it back to a number, because it really is a number. You also have factors. You often deal with factors. So usually if you have a condition, you want it stored as a factor, not a character, so that you can treat it sort of as a nominal category. But sometimes it doesn't, it's hard to know which kind it is. So if I were to copy in, the members of the Brady Bunch, Greg, Jan, Marcia, etc., these end up being just a character string. So if I do, actually I'm not sure what's going to happen if I do type of here. I wonder if I can swap the order of these. Not really. Okay, so it comes up as a character string, but really we don't want it character strings. We want these to be treated as sort of different levels of a factor. So we can use the as factor function or just the factor function. Both of them will work in this case. So interestingly, the type of this comes back as an integer. But if I say as factor, you see we've got these, and then it tells me the levels. Now the levels are placed in alphabetical order. Even though they're not put in that order, they are returned in that order. So this, so you can, if you have multiple levels and they're in alphabetical order, oftentimes the output will be done in the order of the factor. And so this is a handy way of formatting things so they have an implied order. See, factor also works. These are categorical, though. There is not really a sense in which one is greater than the other. So a factor could also be done with numbers, in fact, which looks a little bit strange. So, for example, BB is equal to S factor, and then these values 5.5, 1, 2, 3, 2, 3.3. So this maybe is a bunch of different doses or a bunch of different time treatments that you might use on a data set. So again, we've got the values still, but then it sorts the levels in sort of numerical alphabetical order. So this looks like numbers, but it's actually a factor. And so there's no sense in which it knows that this is really greater than this. It places them in the order, but it doesn't have a sense that of the scaling of it. And if I want to get back, so I could transform these to numbers. So I could transform, let's see, BB, I could do as numeric BB. But look what happens. It doesn't transform it back to the actual original values. It transforms it to the ordered values. So just like this thing came up as an integer, implied is this alphabetical or order of the factors, that if I try to get it back to a number, it will use that instead of the labels. These just are text labels that look like numbers. So that I could actually get back the numbers if I first transform it to character. So if I change to a character, you can see it pulls the name of these factors out. And so I can do as numeric of as character BB and get the numbers back. So that's a way of transforming it back and forth. We could, there's times when you'd like to treat numeric values as a factor, of course. So for example, if you're doing a model, a predictive model, you might have different doses of a drug, 0, 50, and 2000, and maybe the benefit of the drug goes up until 50, but at 2000 is a lethal dosage. It's just way too much and people start dying or animals start dying or whatever. So if we don't have a sense that we really want to model the impact, which might be the benefit, as a line with the dose making having equal consequence on the benefit. So if we change it to a factor, we see it has these 3 levels, and again they're in numeric order, but they're categorical. They happen to be this. So this would be an easy way of just deciding, well, I want to use it numerical or I want to change it to a factor. And it's pretty common to have a numerical predictor like maybe day of the week, hour of the day, order, that you decide that because it has a nonlinear effect or something, you don't want to treat it as a numerical predictor and you want to treat it as a factor. All right, so that's some information about the different data types that are available within R, and there are others to make that are available within special packages and things like that as well. But these are the basic things you should know. Now, next, section 1.7, we want to talk about filtering and selecting and removing data. So in general, what we're going to have is a series of data now that we're going to always be dealing with. So rather than just single numbers, we'll have a set. And just so you can get the same numbers as in the book, you can do this set seed. This sets the random number generator, so it will always create the same values. And I'll create 100 random variables. And then I'll take that first set and add another 100 that have a slightly different scale. And if we wanted to plot x versus y, we can see, well, they're highly related. Now, let's say we see that there's some that are above zero point 0.5 and some that are below zero point 0.5. What if I want to pick out the ones that just happen to be above zero point 0.5? So I can create a logical variable by using a greater than or an equal to or less than test. And if I compare x, which is the first set of random variables, to that value, this will create a sequence of trues and falses. So here, we have a false if that first x was below 0.5 and true if it was above. Now remember, these are always between 0 and 1, so this is going to be about half of the values. If I say sum, it happens in this case to be 39. So maybe we'd expect if things tend to be above 0.5, they'd be more to the right. Well, x is a normal random variable, and it's on this axis, so maybe we want to pick out just the ones to the right or to the left. So this should pick out the ones just to the right. So how do I get those? This is still 100 long, and it has true, false values. This is still 100 long. Well, I can use the same brackets that I use to select individual values, and I can say x bracket temp, x bracket temp, and this will only this will create a subset that only picks out the ones for whom temp is equal to true. So you can see if I do that, this picks out 33, picks out 39, just like we saw. It picks out the 39, and you can look closely, and every single one of them is greater than 0.5. Even this one that was just barely greater than 0.5. So that's a simple way of filtering. If I want to pick out the other ones, I can do x not temp. So the exclamation point picks out the opposite ones. And here we've got 61 of them, and they're all less than positive 0.5, including this one, and this one, which is not too much less than positive 0.5. Okay, so that's one way of filtering. This can be really useful in plotting, in making plots. So an example might be that I want to plot everything that I want to plot the things where temp is greater than 0.5 in one color, or I want to plot only those. So here I'm plotting. Actually, it's range limited, so I could. Xlim should probably be bigger than 0 to 1. Maybe I want to do like this, and ylm 0 to 4. And so then maybe I want to also plot the other ones in red. Oops. So plot creates this plot. Points is a function that works like plot, except it doesn't create a new plot. It just overlays the plotting on top, and it'll also not do the additional adornments. So it looks like if I do -4, I can extend the x-axis and y-axis. And now I have overlaid two different plots on the same graphic, where I plotted the ones greater than 0.5 in green with open circles. Green was specified by the color. I didn't specify a PCH value, so that's what the default is. And the other is red, specified by PCH16, which is a filled circle. And so I filtered out just the one set, and then I filtered out the opposite and plotted it that way. So you can add more layers than just this. With standard R graphics, one of the nice things is you're not sort of limited to a single graphic, and you can draw a lot of things on top of them. So let's see. This is, well, I'll just do this one. And now one thing you can do is add axes of different areas. You can add lines. And here I added, a small axis that might fill in some specific area, or I might want to try it a slightly different way. I have these horizontal and vertical lines to help me see where the center point is of that decision point and things like that. Now what I did here is I plotted first the green, and then the red. I could actually do that in one argument by specifying not just a single color, but a bunch of colors. So let's think about what temp is. Temp is choose and falsus, and if I say temp plus 1, we see it's going to be 1, 2, 2, 2, 1, 1, etc., just like I showed before. So if I now if you think about this, if I have 1, 2, 1, 2, 2, 1, 2, and put it in brackets after a vector, it's going to pick out red, green, 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 red, red, green, 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 green. So let's look at that. So you can see red, green, 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 red, red, green, green, green. So this is a little hard to grasp at first, but it should, if you think about it, it should make sense. So this bracket doesn't just subset, but it will pick out any sequence. And because I created this so it's only 1s and 2s, it'll pick out 1s and 2s. So knowing this, I can create my graphic so I don't have to do it in 2 pieces. I'm trying to copy the code from my file. So now I plot X and Y, but specify the color, and that color is going to be a vector that specifies the color of every single element. I could have specified this by hand and colored it however I wanted, or some other way. I could have specified it sort of a rainbow color, so it goes from red to blue across all the colors of the rainbow as I move from here to here in some other functional way. But this will give me the plot all at once, and I use a different PCH, which is a character value here. I could also use that same trick to change the plotting character. So here's another one. So I have the color here, but then I also have the plotting character, but I'm going to now do sort of an implicit definition for the Y value. The plotting character will depend on the Y value. Okay, so now let's look at this. The color is specified by temp. Temp is specified by the X value, right? So somewhere right here is 0.5, and we'll see anything to the left of the 0.5 is green, anything to the right of the 0.5 is green. Left is red, right is green. And then the second one, the symbol is specified by a vertical line at 0.5 as well. So you can see everything below this line is an open circle and anything above the line has a closed circle. All right, there are a couple exercises in the course book that you should look at now. I'm going to move on to a little more advanced training about report generation in R. So this is handy to, if you save a file like this is handy to save a bunch of stuff. Let's see, we'll call it chapter 1, 2. But what you end up with is running all of this, getting output. If you have statistical results, you have to sort of copy this to a file, another file, and save it. And there's probably pioneered by Mathematica. There's for a while been this notion of notebooks, and now their notebooks are available within R. They're available within Python, available within Mathematica, and probably other tools. But so instead of just adding a script, you can add a notebook or Markdown. And notebook, we'll use Markdown because Markdown can be used to create specific types of documents, and a notebook sort of lives within our Studio, although you could also export it. So I'm going to make a Markdown here, and it will, unless I'm missing some libraries, we'll create a new file here. I'm guessing I may have to stop while I load this. All right, to use Markdown, at least on this installation, it required all of these additional libraries, and so it's going to install these automatically. And it gave me a warning, and I said install it, but you may need to go to packages and install some of these by hand. But I'll just pause until these get installed. Oh, there, it's done. So RStudio usually comes with most of the stuff you need for Markdown, but not always. So with a Markdown, you give a title, chap, and you type your name, and it's gonna, I think HTML is the easiest because it will make something directly. PDF requires installing LaTeX, some version of LaTeX on your computer, and so that might be much more complicated. Word will create like maybe a RTF file that Word or OpenOffice can read directly, and this can be really handy, especially if you're making other documents, because you can copy figures around and tables around and things like that. I'm going to try just HTML because it might be easier to try. So it creates this Markdown file, and it's got this title, author, date stuff in it, what type you want, and then different sections. So if you are, turning in homework for a course, you might title it here. And now the Markdown works, but it lets you write text. So here's the text, and the text can be formatted. So the pound will do a large title, a single pound will do I think a smaller title, or maybe it's the opposite. The star will make bold and things like that. So you can write text so you can describe what you're doing, and then you can include R code, and you include R code by this little idiom you do, back quote, back quote, back quote, and then in paren R, or in brackets R. Now any code you put in here, I could say A is equal to 3, B is equal to 4, C is equal to A plus B, and then maybe I'll print C. It will run this. Now there's a couple ways of running all of this. One is running it within the RStudio window, and I can push this button and it will run that. And you can see that C printed out and it's equal to 7. This, when they say add, when they say like R pressure, this binds like a data set to this little scope. There's also, so I think if we plot, this is a data set that's available. Anything you run in here is going to be available within the console. So if I type pressure, I can see what the values are. So it plotted this data set, pressure, fairly simply. There's also a lot of different arguments you can put in here. Like echo false gets rid of a bunch of messages. Warning equals false will also get rid of sort of warning things that might appear. And you can also do fig. There's a lot of things to control the size of the figure. Fig height equals 8. So if I do this, now the figure that gets created will be really tall, 5 inches wide and 8 inches tall. And notice it doesn't appear over here anymore under plots. It appears only down here. So I can sort of build these things piece by piece, documenting it along the way, and at the very end, if I want to have a file to turn in or save, I can do it this way. I can say chap1 HTML. Oh, this, it's trying to save RMD. It's trying to save the Markdown file. It recommends that you name these with extension capital RMD. So now a new little panel appears here where it's putting this all together, and it will actually just pop up in a new window, the Markdown, and it'll look like this. It's nicely formatted, and it's got my name and the date. I could, if I have things set up, have an account online that I publish this directly to. I could open it in a web browser. I could print it out and save it. I could also knit to, say, a different type. So I don't think PDF is going to work here, but I could knit to Word. And now it's going to create the same thing. It's going through its processing and should appear any moment. And it will pop up probably directly in a Word document once it completes it. Okay, I haven't used Word on this account previously, so it's trying to do all the setup. All right, well, I think that if it's here, it might be behind. Okay, it's not loading because it wants me to fill out all this stuff for the first time I've used this, but it will create and load a Word document that you can then use. All right, so the final piece, let's see. The final thing to think about is how you want to use this versus sort of non-Markdown files, and how to arrange these all within a folder. So what I will typically do is make, for any given project, there'll be a folder or subdirectory that I save that has my Markdown files and data files I read in all together in one place. And if it's looking for that data file, it's going to be looking within the working directory. So it's always important once you open and load a new Markdown or file or R file to go to Session, Set Working Directory to Source File Location, so that if you save output, it will appear there. Or if you load input data, it'll look there. Some people like to hard code locations of files within the R script. And we'll see maybe in the next chapter for reading in data how you do this. But so they'll say, I'm going to look in my home directory / documents / data analysis or something. The downside of that, of hard coding it in here, is that if you give this file to someone else, they won't be able to use it unless they have exactly the same file structure as you do. So I found it's better to refer to the relative location and just make sure they're all packaged together. You may also want to try to use projects, which can simplify some of this, but it also makes it also a little harder to exchange because not many people use these projects, but it can simplify keeping separate data environments for different projects if you're working on multiple projects. You should also use sort of the initial Markdown to do any initial data processing, and I like to avoid as much hand coding of your data as possible, and so you should sort of have your raw data and be able to process, do all the outlier removal or whatever in some set of commands within an R notebook or an R syntax file, so that you could recreate everything if something goes wrong from the raw data. It's sort of bad practice to edit data from your files directly because it sort of is an undocumented way and it's an easy way to screw things up. So those are some tips about saving these files, how to manage them. I like, for any project, if it's like a homework problem set, you keep all of these things together but separate from everything else. And especially if it's a homework that you're turning into professor, you should think, can they run this, or are they going to have to edit something in order to run it? And so try to organize it if it's something that you're turning in, so that to someone else that they can run the same thing that you can run just by setting the directory to the right spot. All right, so that's the end. Stay tuned for chapter 2, which will cover, let's see, chapter 2 will cover data handling, reading and filtering and aggregating data, and applying functions to data frames. So in this course, we're going to spend a few chapters before we get to any actual statistical analysis, so that you know how to manage data prior to doing inferential testing. All right, thank you.